When you are given a set of data points, you could graph those data points onto a Cartesian plane in order to determine if the relation will be linear or nonlinear. We know a relation is linear if the data points graphed form a straight line. But we may not always be able to graph our data points, and so there has to be a way for us to determine whether or not our relation is linear or nonlinear. In order to do that, we can use a concept called first differences in order to figure out the type of relation we are dealing with. When we calculate first differences, we are focusing only on the y values that are given to us in a table of values. And so when we calculate our first differences, if we find that first differences are constant, meaning we get the same number showing up in our calculations, we can then state that the relation will be linear. If the first differences, however, are not constant, meaning when you calculate the first differences, you get a different value every time, we can then conclude that the relation is nonlinear. And then if we graphed it, we would see that it wouldn't make a straight line, it will make some other type of shape. So let's take a look at a table of values and talk about how to calculate first differences. So in my table, I see that I have a column of x values and I have a column of corresponding y values. When we calculate first differences, we are only going to be working with the data points that are in the y column. So the first thing that we're going to do is we are going to add on a third column to our table, draw in all of the corresponding rows. And what you can do is you can actually block out this first row here. And I'm going to call this FD, which stands for first differences. So to calculate the differences, this is going to sound super cheesy, but you can actually think of Drake and his song Started from the Bottom, because that's what you're going to do. You're going to start in the bottommost row of your first difference column. So in our bottom row, what you're going to do is you're going to look at the last number or the bottommost number in your y column. So I see that I have a -9, so I'm going to write that down. And from -9, I'm going to subtract the number directly above it, which for us is a -5. So I'm going to put that in my column. Remember to be careful with integers. If you have a negative number, make sure that you encase it in brackets, so that way you do not mix up your signs. So this is -9 minus -5. Okay, then I'm going to move up a row, and that's going to take me to -5. So in my next row, I'm going to write -5 minus, and from that, I'm going to subtract the number directly above it. So the number directly above -5 is a -1. And I'm going to continue this pattern and subtract the numbers directly above until I fill in my entire column. Okay, so now I'm ready to subtract. I'm going to start at the bottom of my first difference column with -9 minus -5, which is -4. And then I'm going to move up a row. -5 minus -1 is also -4. -1 minus 3 is also -4. And 3 minus 7 is also -4. So when I look at the answers that I have gotten in my first difference column, I noticed they're all the same. -4 is the constant value that appears in my first difference column. So knowing that, remember we stated up at the top of our lesson that if the first differences are constant, our relation is going to be linear. So I'm going to fill that in here. My type of relation is linear. And the reasoning that I can provide for knowing that it is a linear relation is that the first differences are constant. Okay, constant means that it's the same value that appears when we did our first difference calculation. So we got a constant value of -4. here's another example. So we've got a fresh set of data points. I added on a third column for my first differences. And remember, you are going to block out the first row because we're not going to actually use that row. So again, you are going to start at the very bottom row of your first difference column, and you're going to look at the y value that is adjacent to it, and we are looking at a 29. So I'm going to start with 29, and from 29, I'm going to subtract the value directly above it. So for us, that would be a 13. And I'm going to move up a row. The value that we see here in this third row from the bottom is a 13. And from that, I'm going to subtract the number directly above it, which is a 5. And then I'm going to continue that pattern all the way up my table. Be careful when you get to this last one here. It is 1 minus -1. And then we're going to go ahead and do all of the calculations. So if we start at the bottom, 29 minus 13 is 16. 13 minus 5 is 8. 5 minus 1 is 4. And 1 minus -1 is 2. So this time, if we take a look at the numbers that we got for our first differences, they're all different. They are not constant in any kind of way. It's a different value every single time that we did our calculations, compared to the previous example where we got the same number consistently in every row. So because our numbers for this example are not constant, we can then conclude that this is a non-linear relation. And the reasoning for this is our first differences are not constant, meaning they are not the same value in our first difference column. All right, now it's your turn to try an example on your own. So here is a fresh set of data points. So you are going to go ahead and calculate first differences, and then when you're ready, you can come back and check and see if you got the correct answer. All right, so if you calculated your first differences, you should have gotten a value of 15 in every single row. So if we look at the values that we got, it is very clear that we got a constant value of 15. And so therefore we can conclude that this is a linear relation, and our reasoning is because our first differences are constant. So what if you weren't given a table of values and instead you were given an equation, and then based upon that equation you needed to predict whether or not the relation would be linear or nonlinear? So we have an equation here, y equals -2x plus 7, and then they've given us a partially filled in table of values. So they've chosen x values for us to use. So they've given us values ranging from 0 to 4, but they haven't given us any information about the y values. So this is going to be something that we need to fill in ourselves. So because they've given us x values, what we can do is take each of those x values and insert them or substitute them into the equation that they gave us in the place of the letter x. So what we're going to do is we are going to fill in the y column. So our equation was -2 multiplied by x, but we are going to fill in the x value that they gave us. So we'll start with the first value, which is a 0. And then we have to add 7. And we are going to continue this all the way down the y column. So our next row would be -2 times 1 plus 7, -2 times 2 plus 7, -2 times 3 plus 7, and -2 times 4 plus 7. So starting from the top, if we do the math, we would get 7, 5, 1 and negative 1. So these are the y values that we can now use to calculate first differences in order to determine if this equation is going to be linear or nonlinear. So I've gone ahead and created my first difference column. I blocked out the first row as usual, and I started from the bottom and I worked my way up and I filled in all of the subtractions from my y value column. So I started with negative 1 and I subtracted the value directly above it, which was a positive 1, and so on. So now I'm ready to calculate the first differences. And I find that every time I do the subtraction, I get a value of negative 2. So because we got the same value consistently in our first difference column, we can say then that the first differences are constant. Therefore, the relationship is linear. And now you can try an example on your own. So we have a brand new equation, y equals x squared. You are given values for your x, and you need to calculate the y column. And then you also need to calculate the first differences in order to identify if this is going to be a linear relation or a nonlinear relation. So you can go ahead, pause the video, try the example on your own, and then come back to check your answer. Okay, so if you took each of your x values and substituted it back into the equation, you should have gotten the following values in your y column. So remember, it is just the value of x squared. So that's how I filled in my y column first, and then I did the calculation. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So those are my y values. And then I went ahead and made a third column for my first differences. I filled in all of the subtraction values from the bottom, working my way up, and then I subtracted and got the values for my first differences. So I ended up with values of 1, 3, 5, and 7, which very clearly are not constant. They are different values every time we did the subtraction. And so therefore we can conclude that because the first differences are not constant, this has to then therefore be a non-linear relationship.